Welcome back to the AI Research Roundup. I am Alex. Today, we're looking at MMaDA, Multimodal Large Diffusion Language Models, a paper from May 21st, 2025. It introduces MMaDA, a new AI built on a diffusion model architecture. These models learn to create data by gradually refining it from an initial random state. MMaDA aims for top performance in understanding text and images, reasoning, and generating images. Key to its approach is a unified design for handling diverse data types and a mixed long chain of thought, or COT, fine-tuning strategy. This chain of thought strategy helps the model tackle complex problems by learning to outline its reasoning steps. So, for those interested in the implementation details, the authors have shared their MMaDA GitHub repository. It contains the full source code for these multimodal diffusion models, so you can run inference and training. You'll also find configs, validation prompts, and an app.py for a Gradio demo, a way to quickly build an interactive web app for the model. Okay, so this first table gives us a nice overview, comparing MMaDA's architecture and training strategies against other existing models. What really stands out for MMaDA is its consistent use of a diffusion architecture for both language and vision tasks, unlike many others that might use autoregressive models, or AR models, which predict things one step at a time for language. MMaDA also employs its mixed long chain of thought fine-tuning and a special reinforcement learning algorithm called UniGRPO for post-training across both modalities. This unified approach allows MMaDA to tackle understanding, image generation, and text generation, all with reasoning capabilities. Alright, so this first figure gives us a really good visual on how MMaDA performs in practice. It shows three types of tasks. First, textual reasoning, where MMaDA correctly solves a trigonometry problem, even showing it step-by-step thinking, while other models apparently couldn't even attempt it. Second, multimodal reasoning, involving a geometry diagram. Here, MMaDA accurately calculates an angle, again outlining its logic, whereas other models get it wrong. And third, world knowledge-aware text-to-image generation, where MMaDA correctly generates an image of a cat based on the prompt about Istanbul's popular animals, unlike others that missed the mark. This really showcases that unified capability we were talking about. Alright, so we've seen some impressive examples of what MMaDA can do. This next figure, figure 2, really lays out the MMaDA pipeline, showing us more about how it's constructed and trained. It details a clear, multi-stage training process. This begins with stage 1, pre-training, then moves to stage 2, that mixed long chain of thought fine-tuning we talked about, and finally, stage 3 involves UniGRPO training. This UniGRPO stage uses specific rewards tailored to different tasks and a clever masking approach within its discrete diffusion generation, which is how the model iteratively refines data from a noisy or incomplete state. The bottom part then shows the inference stage, where inputs like text or images are first processed by tokenizers. These basically break down the input into pieces the AI can work with, before MMaDA generates those reasoned outputs. So building on how MMaDA generates outputs, this next figure, figure 3, gives us a qualitative comparison of different sampling strategies for image description. We see a painting of sunflowers, and the model is asked to describe it. The figure contrasts a standard fixed-length generation with a semi-autoregressive approach. This semi-autoregressive method, which is a way of generating content that's partly step-by-step, like traditional methods, but also partly in larger chunks, results in a dramatically more detailed and nuanced description of the painting. It really shows the advantage of this more flexible sampling for capturing richer information. Okay, so beyond just generating rich descriptions, let's look at how MMaDA stacks up quantitatively in understanding different types of multimodal inputs. This brings us to Table 2, which evaluates MMaDA on several multimodal understanding benchmarks. We can see MMaDA compared against both understanding-only models and other unified understanding and generation models. Across various benchmarks like POPE, VQAV2, and MMV, MMaDA achieves results that are either comparable or even superior to specialized models, and it consistently outperforms other unified models. This strong performance and understanding really underscores the benefits of its mixed long chain of thought fine-tuning and the UniGRPO training we discussed earlier. Alright, so after seeing MMaDA's strength and understanding, Table 3 shifts our focus to its image generation capabilities. This table evaluates MMaDA against both specialized generation-only models and other unified models on various benchmarks. Notably, MMaDA achieves the highest key uplift score, which measures how well the generated image semantically aligns with the text prompt, and the highest image reward, a metric reflecting human preference for the generated image. It also scores best overall on GenEval, a benchmark assessing how well the model handles complex prompts involving multiple objects or attributes, and performs exceptionally well on the WISE cultural benchmark, likely thanks to its joint training on text-based reasoning. Okay, so MMaDA isn't just good at generating images, it's also strong at reasoning. Figure 4 gives us a qualitative look at this, specifically for multimodal reasoning on a geometry problem. You see a diagram of a triangle with some angles given, and the question is to find another angle. While other models like Showo, Emu3, and Janus Pro 7b provide answers, MMaDA stands out by showing its detailed, step-by-step thinking process, labeled with "less than think greater than" and "less than / think greater than" tags. This clearly demonstrates that mixed long chain of thought fine-tuning in action, leading to a reasoned solution. It's clear that MMaDA really excels not just in understanding complex multimodal inputs, but also in generating high-quality, reasoned outputs like we saw with that geometry problem. The key takeaway here is how its unified architecture, boosted by that innovative, mixed, long chain of thought fine-tuning, allows it to be so versatile. This kind of progress is super important for building AI that can truly interact with and understand our world in a more holistic way. Thanks for tuning in to the AI Research Roundup. I'm Alex.